unless you rely on your pen as opposed to your calculator. Okay, there's no answers in the pen. All the answers are in the calculator because we can come up with the numbers by manipulating the data in the calculator. One of the concepts we need to talk about is something called population versus a sample. Hopefully you've got the idea here. Okay, the guy on the video said, take a slice of the United States. Okay, that's the sample. The population is the whole United States. The population that I'm thinking about when I'm going around trying to figure out something for IBM is all the people who might buy the IBM product. I don't get to talk to every one of them, but I take a sample, maybe of a couple hundred people. The people who are developing the new type 2 diabetes medication are worried about all the people who have type 2 diabetes, but they don't get to see and work with every one of them. So they take a sample, right? They look through the sample. So the population is essentially the whole group that we're interested in. The sample is this slice that we get to see. Now we hope that the slice is a very good representation of the whole population. Because if the slice of pizza we eat doesn't taste like the rest of the pizza, then our conclusions are going to be off. So we've got to select a slice of the pizza that is look, feel, taste, represents the whole rest of the pizza. Does that make sense to everybody? It's harder said than done. Let me give you a really bad example. I was actually in the math center a couple of years ago, and these three guys. I mean, I hate to pick on guys, but they were three guys. Three guys come in, and they weren't in my class. They were in another class, and they said, well, "We're really, we need this course to graduate in like May, and we're like let it all go to the end, and we're doing this final project for this math class." And I said, "Well, okay, so tell me what you need help with." And they said, "Well, we're really let it slide, but we're trying to get to our final project together." And I said, "What are you doing your final project on?" They said, "Well, we're doing our final project on the smoking habits of people at CLC, students at CLC." And they said they were supposed to collect, I thought it was 120 different responses. They were supposed to talk to 120 different people. And there were three of them in this group, and they had actually decided, okay, well, each one of them is going to talk to 40 different people, and they're going to get together at the end, they're going to pool their data, and they were going to then, going to do the next parts and, present the project and stuff. So I asked the first person, they said, well, okay, so let me see the data, and, and they said, well, here's my data, and the next person, here's my data, and they all had 40 of them. And I said, well, the first person, I said, well, how did you guys decide how to collect the data? Where did it come from? So the first person says to me, he says, well, I just asked everybody in my two classes, okay, what their smoking habits were. And he had a little survey and got the data from everybody in the class. And I said, that's okay, but, that slice of the pizza may not perfectly represent, night students, day students, weekend students, people in other classes. Okay, that's a slice of the pizza from just the people in your classes. So it's not bad, but we got to worry about it a little bit. So the second guy says, he says, well, what I did was I randomly selected day parts for the whole week, Tuesday afternoon, Friday morning, and I went over to the common area and I actually accosted people and I said, could you, give me 5 minutes and take my survey, and he said, I tried to randomize when I was there, and I asked every fifth person that I saw coming through the area, and so, well, that's pretty good. That's a more random approach. That's an approach that says I'm probably more likely to get the kind of average CLC student, right? And the last person says, I was a little delinquent. I went out to the sign that says no smoking beyond this location and just waited for people, and I asked all the smokers. So I know I'm beating a dead, that's a true story, and I know I'm beating a dead horse, but the slice of the pizza that they now have is maybe not going to give you the right conclusions, right, for the average CLC student, because they didn't really collect the data, kind of appropriately. All right, And so they're trying to make some inferences about the population, which would be all the CLC students, but their sample is a little suspect, okay? Very suspect, actually, okay? I don't know what kind of grade they got, but they didn't do well on the sampling part, okay? So everybody got the idea between the population and the sample, right? We understand the difference between the population and the sample. All right, so let's talk about two other terms, a parameter and a statistic. And I'm going to put parameter under population for a very important reason. Because parameters describe populations, statistics describe samples. Now, what do I mean by that? Well, a parameter is a characteristic of a population. And so, for example, if I was able to talk to every IT manager that buys computers across the world, and I say to them, how much money are you willing to spend next quarter on your computing capabilities? And I averaged that, and I actually had perfect 100% information from every IT manager in the world, then I would be able to calculate a parameter, which in this case would be the average spend next quarter. And that would be a parameter. It would actually be the true, what we call mean, averages arithmetic mean, so we call this mean. But it would be a parameter. It would be a description of the whole population. Now, we rarely get to do that because it's too expensive, too time-consuming. We don't get to talk to everybody. We don't get to see everybody. So normally what we do is we have a sample. And if we actually take our sample, and if I talk to 200 people, and I take the mean from the sample, then this is called a sample mean. This is a population mean. So a sample is a number, or a parameter is a number that describes the population characteristic. A statistic is something that describes a sample characteristic. Does that make sense, everybody? And normally, we're only left with the statistics. And we use those statistics to kind of infer or guess at what the population parameters are. And that's a lot of what we do in statistics. How many people have ever heard of Nielsen, AC Nielsen ratings, TV ratings? Anybody ever see, you know, I said the #1 TV show this fall? Well, how the hell do they know it's the #1 TV show? I mean, CBS says, we got the best TV shows of all the networks. How do they know? You know how they know? They measure how many people are watching that TV show on that night. Who's they? Well, it's a company called AC Nielsen, TV rating company. Anybody have a little box in their company, in their house that's measuring what you watch? I don't. So how do you know what I'm watching? Do you have a box in your on your TV that says, "Oh, what's Stacy watching tonight"? Does anybody have a box in their house that measures what you watch? But yet I can read in the paper that I watched this show. Right? 27% of the country watches the Super Bowl. How did they know that? They didn't ask me. Did they ask you, Joe? Did they ask you? How many households in the United States? Anybody have any idea? 308 million people in 2010 census, right? Maybe 314 million people in the country now. Each household is probably a little less than 3 people on average. Okay, so I think there's somewhere between 100 and 110 million households. You know, little boxes of heat and, you know, that have TVs in them. The Nielsen Ratings Company sells information to all the networks that says this is what people watch. How many boxes do you think the Nielsen Company collects data from?
30 to 60,000.
Huh?
30 to 60,000.
That's a really good guess, okay? I think it's
20,000.
I think it's more close to 20,000 homes that the Nielsen Company is. So they're only talking to 20,000 people. That's their sample. But they say, I know from the sample that I can infer about the whole TV watching population. And this is big money, folks. I mean, the company makes a lot of money doing this, okay? But they don't get to see the whole population. They sell statistics based on a good sample. And of course, they're very, very diligent about making sure it's a good sample. A good sample for them means they have all demographic groups, all age groups, all geographic parts of the country. I mean, they have to actually have a good sample. But it's a sample. All right, so parameter and statistic, okay? Let's talk about one more definition and then go. Descriptive and inferential statistics. Descriptive statistics, in fact, actually, I should probably write these the other way. Descriptive over here. Even though descriptive could apply here, most of the time it does not. Descriptive statistics means that I simply am making charts, tables, numbers from the data that I have in front of me. Now, if I'm really fortunate and I have the whole population worth of data, I can make descriptive statistics over here. But most of the time, I have a sample of data, so I am describing the data I collected. Now, inferential statistics typically means using the sample to infer. Nielsen is using the sample of 20,000 households to say, I know that this is the percent of the whole US TV watching nation that was watching this show that night. So inferential is making an inference. The doctor who develops the medication for helping diabetes 2 is making an inference about the whole diabetic population that says this medication will help, okay? So that's inferential statistics, okay? Questions? All right, let's collect some data, but let's talk about different types of data.